Hello everyone, today me and my friends will be presenting the multiple standard addition method which used in our CHM580 experiment to determine the concentration of Fe3 plus ions in a natural water sample. But as for this session, we will focus on how to find the standard volume Vs we assume added. So let's consider this question to be solved. Based on this question, a multiple standard addition method was used for determining Fe3 plus ion in a natural water sample. 10 ml aliquots of the sample were pipetted into 50 ml volume flask, exactly 0, 5, 10, 15, and 20 ml of a standard solution containing 11.1 ppm Fe3 plus ion were added to each, followed by an excess of thiocyanate ion to give the red complex ion. After the dilution to volume, absorbance of the 5 solution were measured in a 0.982 cm cell at 480 nanometer and found to be a 0.24, 0.437, 0.621, 0.809, and also 1.009 respectively. What is this? We want to find the concentration of Fe3 plus in the water sample. But for our session, we want to find the volume standard. So as stated in this experiment, 10 ml aliquots of the sample were pipetted into 50 ml volumetric flask, which exactly 5 flasks, which is first is 0 ml, 5 ml, 10 ml, 15 ml, and also 20 ml. This is assumed as standard solution, which is Vs. Then for based on the equation, 11.1 ppm Fe3 plus assumed as the standard concentration, which is Cs. Then after added the volume of standard solution, we dilute it until total volume, which is 5 ml, as based on the equation. This we have doing the table for more understanding, which is for volume standard 0, which is absorbance 0.240, and so on. This we want to proceed about the equation.
In this calculation, we are going to use Beer-Lambert's law and multiple standard addition. Why we choose multiple standard addition? Because the question use more than one standard solution. So from this equation, first we know that Cx is equals to unknown ferrum concentration in original sample. Bx is equals to volume of sample added, which is 10 ml. Cs is equals to concentration of standard, which is 11.1 ppm. Vs is equal to volume standard added, and Vt is equals to total volume after dilution. So in this question, we combine these two formula to get this. So we rearrange it to make it easier for us to calculate. And then we're going to assume that K equals to epsilon B over Vt. And then we're going to get this. Next, we move on to the next calculation step.
Okay, let's continue. So in this question, it's required the student to create a graph using Excel. But in this section, let's just assume that the graph here already been provided by the question. So as you can see here, when we plot the absorbent versus standard volume of standard added, we obtain a straight line that aligns with Beer-Lambert's law within a measured range. So from the graph, we can obtain y equal to 0.0382x plus 0.2412, which same equation as y equal to mx plus c, which is m is equal to 0.0382. So this equation also aligned with a equal to mvs plus b, and is also aligned with a equal to KCS Vs plus KVS CS. From our data, we obtain M is a slope, which is 0.0382. Then this slope can be substitute in this equation. So we can obtain A equal to 0.0382 Vs plus B. So we need to find the value of our B. So let's just take any point from the graph. So we use A equal to 0.240 and VS is equal to 0. So when we substitute into the equation, we get B equal to 0.240. So to find standard volume that corresponds to zero absorbent, we set A is equal to 0 in this equation. So when A is equal to 0, we substitute all the information given, which is B is equal to 0.24. It's come from here, and the slope is 0.0382 where obtained from the graph. So when we calculate, we get negative 6.28, which is the final volume is 6.28 ml. So the negative volume is obtained through extrapolation, meaning it represents the theoretical volume of a standard that would need be removed to reduce the absorbent to 0. In the other words, it showed the equivalent amount of Fe3+ already present in the original sample. So in conclusion, the multiple standard addition method is reliable technique for quantitative analysis, especially when matrix effects are present. It provides accurate result without the need for external calibration curve, maintains consistent dilution condition, and also increase analytical precision. Overall, this method effectively corrects for interference and give a more accurate determination of Fe3+ concentration in a real sample of a natural water.